Thank you all for joining us today. The purpose of today's webinar is to give you an introduction to some of the new features in SQL 2017 that we feel are innovative and interesting. Now, you might recall that SQL 2016 came out not too long ago, and also there was a service pack to SQL 2016 that was also recently released. Now, you may assume that Microsoft has just put in place a new versioning scheme where any release in a year gets versioned based on that year. We're in 2017. Microsoft has some updates for SQL Server, so let's just call it SQL 2017. But that assumption would actually be incorrect. SQL 2017 is a huge release. This is the first version that makes SQL for Linux an official product that's supported on Red Hat Enterprise Linux, SUSE, and Ubuntu. Additionally, SQL 2016 also adds big updates to enterprise features, but those features aren't available just to enterprise customers like they used to be. With the release of SQL 2016 Service Pack 1, Microsoft essentially opened up all enterprise features to all versions of SQL Server, including Express and even local DB for some of the features. SQL 2017 continues with that trend by including new features that we'll be talking about today and that are also available across nearly all versions of the product. Where they're not available, it's primarily based on the abilities of that product rather than licensing. One of the interesting side effects of what Microsoft has done here is to try to build an ecosystem that is based on a compelling feature set rather than being based on Windows. So rather than taking the same approach that they've always taken, which is offering integrations to Windows products, SQL 2017 itself includes many compelling features that basically serve as a small ecosystem in and of itself. And that list of features is actually pretty extensive. When you look at the product as a whole, there are very few areas of SQL Server that weren't touched by this update. We don't really have much in the way of new data types that were added, but other than that, with that small exception, SQL Server has been updated from top to bottom. And some of the new features are small, some are big. Some aren't really features at all, but more architectural changes. For instance, SQL Server reporting services, which I know some people that are attending today use, that used to be part and parcel of SQL Server, and now with SQL 2017, it's actually a separate product that you install separately. They've really broken it out in that way. Also, SQL Server Management Studio is now a separate download that's versioned separately so that it can be developed independently of SQL Server. And in fact, the main download for SQL Server, the main install, doesn't even include the Management Studio. You have to go and get that separately now. But let's get back to some of the features. If you'll recall, SQL 2016's major new features focused on security. So we talked about some of these in a past webinar. There was things like dynamic data masking, encryption at rest, row-level security, and more. It also had this new analytics, this advanced analytics engine that uses the R programming language. There were other features as well, but these were the big headline features that everyone talked about that were what they showed off. Now, in comparison to that, SQL 2017 doesn't really have a headline feature because it has so many new big features in it that it's hard to pick just one or two that you could view as the most important or the standalone to make it a headline feature. These are just some of the ones that we found interesting. And we actually don't have time to talk about all of these, but we pulled out a few of them that we think you guys will enjoy seeing. We're going to talk about resumable online index rebuilds. Now, index rebuilds have, online index rebuilding or reindexing has been in the product for quite a while, but this is something a little bit different. We're going to talk about automatic database tuning based on the query store. We'll go into graph database support, and then we're also going to go over machine learning using Python for our example in this case. So the first feature that we're going to talk about is automatic database tuning. Now, one of the main tasks for a database administrator is to monitor the workload and performance of queries as they hit the server. It's one of the basic tasks that they always are dealing with. It's difficult to do. There's lots of details you have to look at, but in fact, it's kind of boring. It's a monotonous task that DBAs have to deal with. And the larger your application grows, the more important that this job becomes. This new feature is meant to essentially lighten the workload of DBAs in this area specifically. The new automatic plan choice correction comes out of a little known feature in SQL 2016 called the query store. Now, this feature, which is turned off by default, so many people didn't know about it, it's essentially a metrics collection system for SQL Server. Its most important metric is the execution time of a specific query plan that the server has compiled from a SQL query from your application. Now, those plans can change over time as your database grows or changes, so query plan optimization is a big area. Automatic database tuning is really the next logical step for this query store that they added in, which basically keeps a history of all the various query plans that have been created. And if we have data on multiple query plans, essentially the way it works is if we have data on multiple query plans that the server has come up with based on some really complex rules that are built into the SQL engine, then it should be pretty easy for the server to determine on its own if any given query plan is faster or slower than some other query plan, and even to track the performance of a query plan over time, which is kind of what we see in our graphs here. If a query plan is getting slower due to some factor in your database, this feature, this automatic database tuning feature, kicks in and it will look at the history for that query and look at the other query plans that were created. And essentially, if it's getting slower, it will select a more optimal plan. So it may go back and look at an older plan that was used at some point and try and use that one, for instance. If the plan that it selected, even an older plan, still isn't any good, it's still is causing a regression in performance, it can even undo that and have the server try a different plan as well. So basically it can handle a multitude of situations in that regard. Now, this is one of those features that essentially if you turn it on, more or less it should just work for you. It will take care of these things on its own. And it's a feature that we're keeping a close eye on. We expect that in future versions of SQL Server, that this is one of those things that's going to gain more intelligence, as more smarts, as it collects more data and has more stuff available to it to optimize the plans and plan selection. And we're actually seeing this already in some areas. For instance, in the Azure version of SQL 2017, this same feature can actually create and destroy indexes for you based on its analysis of your system and its utilization. So they've taken it already a bit further on the Azure platform. And it's one of those things where you may have had indexes that are very rarely used, and it determines that, well, we don't need that index right now. And so it can actually go in and remove an index that isn't being used. Or if there's an index that for whatever reason is structured improperly, it'll leave that one in place, but it may go and create an additional index that is more optimized for the type of query that you're doing. So it kind of fixes some of the areas where we may have neglected our database in some ways. Pretty neat feature. So that's automatic database tuning. Now we're going to talk about one of the really neat features that we have in here that I'm most excited about, graph database support. Now, graph databases aren't anything new at all. Oracle has had graph support in some form in their product since the 1990s, maybe the mid-1990s, somewhere in that time frame. SQL Server is definitely playing catch up in this area, but they've done a pretty decent job for the first pass. For those of us that have been focused solely on the relational database world, the graph database may seem somewhat foreign, but in fact, the idea of it is very simple. Graph databases give us a way of representing many-to-many relationships in a more elegant fashion. The way most of us do this now, that you probably have all over your applications, is association tables, which are also known as bridge tables or cross-reference tables. All are the same thing. The problem with this classical model for many-to-many relationships is the complexity in walking the associations. To illustrate, what we're going to do now is implement this diagram that we have on the screen here in our slide using a relational model of bridge files, and then we're going to look at the same structure implemented using graph tables instead. So we have a pretty basic diagram here, and this is all of the examples we're going to look at are the examples that Microsoft has provided for some of these things. So essentially we have a restaurants table, restaurants persons table, and a city table, and then we have these bridge files or these relationships that are many-to-many relationships between these various tables. So for instance, a person can like a restaurant or multiple restaurants. A person can essentially have other people that they're friends with. City person relationship, lives in. Person likes a city also is another possibility there. And of course, there's a relationship between the restaurant and the city as well. So quite a few bridge files in this example. So let's go ahead and take a look at this in code. And we're going to skip some of the code for it, but let's see here. So I'm going to go into SQL Server Management Studio here, and I've got everything up that I need. And our first example here is dealing with this in the very classical style with bridge files. So we actually are going to go to something that creates a full database of this example. And essentially we've got three tables here, city, person, and restaurant. And then you'll see various other tables that are our bridge files here. So person, restaurant likes, person, city likes, person, friends, restaurant, city, person, city. We have all of these bridge files to connect these tables together in the fashion that were shown in our in our diagram there. And then we have just some data being inserted here. But the key here is really if we're looking at all of these tables that you'd have to create here, and then how do you go about querying for various situations? Well, we have three different queries down here that kind of illustrate how things would work in a standard relational model. Find restaurants that John likes. You can see to do that, we have to cross-reference using the person restaurant likes bridge table between restaurant and person, and just limited to John. Find restaurants that John's friends like. So that one is going to involve the bridge file related to persons, and of course also the person restaurant likes bridge file as well. So we've got a couple of things there. And then find people. This one's really interesting. Find people who like a restaurant in the same city they live in. Now, the key is not how all of this is implemented here, but there's a lot of complexity in getting these queries right. So this one has 2 left joins. This one needed a left join and 3 right joins, 5 inner joins on this one to get to the data that we needed. It can be very difficult to keep all of this in your head as to how you would go about finding this data easily. So let's go ahead and we'll just run this whole thing. And you can see that the relational model works. It's fast, simple. There's nothing special here. It's, again, that basic example, but there's a lot of complexity in the setup related to this. So what we're going to look at now is how to do the exact same thing using graph tables. So graph tables are made up of what are called nodes, which essentially are you can see the person, restaurant, and city are viewed as nodes, and they're connected with edges or edge tables. So our basic node tables are very similar to a standard table. The only thing different is that they're defined as a node in the create table statement. Our edge tables are significantly simpler than our bridge files to create. So you can see that there's nothing that relates these edge tables to the nodes at all. We've got a likes, a friend of, lives in, and located in as edge tables, and you can see that the likes allows for a rating as well. These are very simple tables because the way Microsoft has implemented their graph database support is that the edge tables are not directly linked to any specific node. So edge tables can be used very dynamically. So if you have this likes table here, right now you could associate a person in that fashion, right? Person likes restaurant, person likes city. But you could add more nodes and use this same likes table to create associations between those nodes using this likes edge table. So they're very dynamic from that fashion and also very easy to build. Now the real action comes into this when we go down to our queries to look at the data. And that's because graph table support in SQL Server makes use of this new syntax. They call it ASCII art syntax. So find restaurants that John likes, no joins. We use a new keyword called match, and you can see that essentially we draw out the relationship, person likes restaurant. For restaurants that John's friends like, person one, John, friend of person two, right? So we're looking for person one that is a friend of John in this case, likes restaurant. That's our ASCII art version of those all of those joins that we have there. And of course it can get arbitrarily complex as well. Find people who like a restaurant in the same city they live in. Person likes restaurant located in city, and person lives in city. Very simple, easy to understand, easy to write, and it makes doing some of these very complex social many-to-many relationships or even other types of many-to-many relationships really pleasant to work on. And of course, because of the fact that this is built for these specific many-to-many relationships, SQL Server can optimize in many ways that it can't with a bridge file. So with a bridge file, Microsoft has to, the SQL Server has to make assumptions about what you're attempting to do. And of course, you have to have your joins right, all of that kind of stuff. But when we look at this from the standpoint of a graph table, Microsoft knows exactly, the SQL Server knows exactly what the structure is that we're dealing with and can optimize for a many-to-many relationship so that our query is nice and fast. Let's see. Must have messed something up in here. There we go. Had a character selected. So same table, or excuse me, same basic table structure, same data in this case. We execute it using the graph structure, and it just works. Much easier to understand. Cool new feature of SQL Server to take a look at. Okay, so let's go back over here now. So the next feature that we're going to move on to is our machine learning example. So we're going to look at machine learning services. So right off the bat, machine learning encompasses a very broad field with the ambitious goal of giving computers the ability to learn. Now, in practice, most machine learning can be described in a more restricted sense as software that improves its ability to perform a task based on experience without the aid of explicit programming. Today, we'll focus specifically on an area called predictive analytics. Now, predictive modeling, which is part of this, is the relationship between an entity's performance and specific attributes of that entity. And it's used to assess the likelihood that a similar entity out of a different sample will exhibit specific performance. So the use cases for something like this, marketing, might use it to help determine customer performance. In a sales environment, it can be very useful in the area of fraud detection, specifically things like risk assessment or anomaly detection. So if we were to have, let's say, a online clothing store, and they're trying to deal with credit card fraud. So on transactions, they're trying to reduce the number of fraudulent transactions they have. One possible way of handling that might be to set someone in a chair that looks at the credit card transactions that are occurring and look for things that they've known to be fraudulent in the past. So maybe where items are being shipped to, or the amount of a specific item purchased, or even something like the sex of the person purchasing it may be out of line with what they would expect for that product, along with other aspects of what exactly was purchased. There's all kinds of things that vendors can look at to determine whether something might be a fraudulent transaction. The problem with having a person sit there and doing that, of course, is that it doesn't scale very well, and you're paying a person to sit there and go through these credit card transactions. But predictive modeling can work very well in this scenario, because basically you're using your transaction history as the training data to teach this predictive model what is a genuine transaction, and things that fall outside of that scope are viewed as possible fraudulent transactions. In comparison, descriptive modeling, a different area, deals with the quantification of relationships in data. So this is classification of customers rather than predictive analysis. So use cases for this are things like recommendation engines for retail systems. This is where recommendation systems come from, is descriptive modeling. So trying to look at the relationship between, for instance, this person and what they've watched to determine what they might want to watch. That's a recommendation engine, or what they might want to purchase. That's descriptive modeling. Data mining is technically an area outside of machine learning, but it uses many of the same techniques as machine learning. Instead of having the end goal of predicting a specific outcome, data mining focuses on finding hidden patterns in existing data. Now, many people may see these things, predictive modeling, descriptive modeling, and they may come to the conclusion that this is just statistics, isn't it? I mean, we've had statistics for a long time that looked at things like this, and that's a totally valid question, but it's a very hard question to answer, because the answer is yes and no. So how do we differentiate between classical statistical methods and what we're calling machine learning in this case? Well, as you can see from this slide, the answer is not just related to the actual algorithm that's used. Machine learning cribs a huge amount of its smarts from formalized statistics. It makes use of ridge and lasso regression analysis, gradient descent functions, Markov chain, Monte Carlo algorithms, Bayes classifiers, you name it. So if machine learning is simply the application of these statistical techniques, why does it get to have such a cool name and so much fanfare around it right now? Well, machine learning does two things that are very hard for a statistician to do on their own. It applies these statistical techniques to huge data sets. When you're dealing with a large data set, even just cleaning and preparing the data can be a Herculean task. Analyzing it in simple ways is certainly possible, but sometimes the data set gets so large that the sum of the data is so great that the generalizations that you're able to make from a very simple statistical analysis are useless. They're essentially generalizations about an entire population, which can be interesting things to know, but they're not actionable data items that you're able to collect using those methods. So that's one of the items that sets machine learning apart, is that its goal is to give you actionable data from these. Because of the size of the data set you're analyzing, different techniques are required. The second item, when we're talking about multivariate analysis, a statistician can pull in maybe dozens of variables at a time to analyze. Factors or features is what they're regularly referred as. And they may use various techniques to weed through those variables to find the features or attributes that are functional on the outcome that they're trying to predict. In comparison, machine learning can automate this process so that rather than looking at just a few dozen variables, you could look at thousands of variables and use a combination of techniques to find what are the functional attributes of this data. And you may even find that the functional attributes change within your data set. These are the sorts of things that you can do with machine learning that you can't do with a classical statistical analysis. So now we're going to take a look at a very simple example. Before we dig into this example, there are a couple of things that you should know. First off, this is a very, very simple example. The sheer number of techniques that can be used to train a machine learning model is staggering, and selecting the right algorithm for your scenario is an algebra all on its own. It's what data scientists specialize in many cases nowadays, is being able to pick the right algorithm to use for any given data set and for what you're trying to predict. If your application has an area where you think some of these capabilities, these new capabilities in SQL Server could be valuable, and you're not sure about how to do some of this on your own, Mertech services team can help you implement a custom solution, help you pick the right algorithm to use for that. But now let's go and look at our demo. So, okay. So we're going to be looking at this sample database here. Let's close out a couple of these guys here. And what we have here is a sample table that contains rental data for a ski shop. And the data has already been cleaned up a bit. So let's just take a look at what the data looks like. Essentially, it has very basic information that we're looking to do an analysis of, that defines the date that rentals occurred, the number of rentals on that specific day, the weekday that falls on, whether or not it was a holiday, whether or not it snowed that day, just some very basic information. So that's what we're going to do our analysis on. And we're going to be using the Python support that SQL Server has added in SQL 2017. Before 2017 in SQL 2016, we had to use the R programming language. But the Python support is actually great because there's a lot more examples out there that you can work from and help with the machine learning support that's built in or that's available for Python. So what we're going to be doing in this case is a simple linear regression analysis of the data. And linear regressions, they work across a huge number of types of data overall. There's tons of areas where a linear regression analysis can be beneficial, but it is specific to the data set that you're using. So in our case, we're able to break up the data in such a fashion that we have what's called a linear separation that we can apply here. That's not always the case, and that's where the algorithm selection becomes very important. And sometimes we may need to use something like a decision tree algorithm, or we may need to use, depending on what we're trying to do, it may be something like a Poisson regression or something like that as well. And one of the things that can be very helpful in this area that we'll certainly send a link to after our webinar today is a cheat sheet that Microsoft puts out with many of the algorithms that you can use and where they're beneficial to use. So in this case, a linear algorithm like we mentioned. And really we're going to be using just the default factors on this algorithm for our model. And essentially there's not much to it here. So you can embed in a stored procedure Python now, and you can see that's what we're doing right in this area. And there's not a whole lot I'm going to really go into here, but essentially what we're doing is we're bringing in a linear model learning algorithm that's in the linear regression library, and we're essentially going to feed it some data and to train the model. So a model needs to be trained off of data, and the data we're using is rental data from the years 2013 and 2014. So anything less than 2015 is the data that we're going to feed into this model. And after we've trained the model, you'll see this pickle here. Pickling is a way of storing objects in a file or transferring objects around in Python. So we're going to pickle our trained model so that we can load it back up later and use it to make predictions. So now I've already done this piece of it. The other side of it, we've already done the training. It takes a while to do, so I'm not gonna do that live because it would just take too long to run. Now, so we already have a trained model loaded into a table in our database here, and actually it's something that we can look at right here. Linear model, and this is the pickled object here. So after we have a model trained, essentially what we need to do is we need to make some predictions with that model. And that's what this SQL does here. And again, I've loaded this onto the SQL Server already. We are going to run this. But essentially what I'm doing here is I am unpickling that model that we have here. And then we're telling it to make a prediction based on rental count. And what we're going to do is we're going to feed in all of 2015's data. So we're going to give it all of 2015's data and tell it to, now we already know what the rental counts were for 2015, but we're going to tell it to analyze everything except the rental count using the model that we've trained and see how it does. How are its predictions based on the month, day, weekday, snow, holiday, and year? What does it come up with as their predicted rental count based on that data for 2015? To do that, what we're going to do is, like I said, I've already put that stored procedure into the server. So all we have to do now is essentially run it. So that stored procedure was already set up to pull in the 2015 data. And so we're going to essentially just come up here and execute this. And this can take a little bit of time to run. And what it's doing is it's going through and making the predictions on about, I think we have 151 rows of data in this case. And as soon as it's done here, it's going to spit out some basic results. And then we'll go in and look at it just a little bit further. Okay, so here is our data that got spit out from this. And essentially this is what was spit out from the stored procedure. This is the output from it, which just gave us some pretty raw data. But I have it also showing us the results as well here. And what we see here is in this column, we have the predicted value that our model was able to come up with based on these columns of data here. And then in this column, we're also showing what the actual data was for 2015. And you can see that the predictive model is very close throughout the data set. It's able to determine almost precisely what the rental count was. It's often very few cases, and when it's off by a very small amount, as you can see here. And there's some interesting things that you can kind of figure out on your own if you look at some of this data. For instance, this was a very high rental count day, and it was predicted as being a high rental count day as well by our linear regression model. Well, let's look at this. So weekday 1, so that's a Sunday. Well, weekends, there's going to be, excuse me, on weekends, there's going to be more people that are able to go skiing, and you'll find very often that the weekends have higher numbers than any other days of the week. And then in addition to that, you'll see that this was a snow day. Well, more people tend to like to go skiing when there's fresh snow, or even when it is snowing. That drove their rental count higher. Now, this day is not a weekend, but is also high. Why is this day high? Well, this day's high because that actually is a holiday. So people are off on that day. They can go in that case. And you'll see that sort of stuff throughout here. When you look at the data, that, well, yeah, a person could have come in and predicted some of this stuff as being the case. But if we go to like this one, this is the very highest data point and was predicted as being the highest data point. Well, this one was a holiday and a snow day as well. And it was a weekend as well. So that drove this number exceptionally high in that case. Linear regressions work very well for this type of data. And you can see this was not all that complicated to do. Picking the right algorithm, of course, is a difficult thing to do. But to give you an idea, this was trained on a pretty small data set. And you can see the time it took. It took a fair amount of time to run here. But if we go back to our original data set, I told it to select the top 1,000, but you can see here there's only 453 rows of data. So sometimes even with small data sets, you're able to get fairly accurate models built if the data fits certain scenarios like this. And there are many, many data sets that have this type of data in them that is easy to analyze. So it's choosing that algorithm and training the algorithm properly that's the key. So what we're going to do now is go back to our presentation here. So essentially that is a very simple example of machine learning. And you can go on and on about this. I mean, I could go into some of the other algorithms. It's such a big field in and of itself, and it has tons of potential in your guys' data sets. So your application's data sets can definitely make use of some of these capabilities. And being able to do this in something as simple as Python makes it a lot more accessible than it used to be. So an exciting development on that front. Now, I will say that getting some of this set up in SQL 2017 for Python, it's a little complicated. The instructions aren't great right now, but this is one of those things that's constantly evolving, and I expect it to get much better very quickly. So the last feature that we're going to look at is Resumable online index rebuilds. And SQL Server has had online reindexing since 2005. This isn't something that's new from that standpoint, but one of the issues that has always been a problem for DBAs is how long reindexes can take. A reindex on a critical table can severely impact the performance of your SQL Server. And so most DBAs still schedule reindexes during low use maintenance windows, or they may even take their server offline and do an offline reindex. The problem is that sometimes a reindex can take longer than this window allows. When that happens, your only recourse was either to impact your users outside of that maintenance window, because the system would be less responsive during that period of time, or to cancel the operation entirely, which was normally what would occur, and reschedule it when you have a longer stretch for maintenance, or maybe even a time frame that you can take it down entirely to do an offline reindex. This, of course, means that on large applications, there may only be a couple of times a year where you can do your reindexing, and regularly DBAs were having to schedule these things over long holiday stretches because the indexes were so large and had gotten fragmented. Then we have Resumable online reindexing. This is truly the holy grail for DBAs. Now, basically, this allows a DBA to spread out a reindex operation over the course of a week, if needed, by pausing the operation. Additionally, resumable reindexing is smart. If you run out of disk space, for instance, the reindex won't just fail, it will automatically pause. And this isn't the only air condition that it can recover from. So the timeout pausing that I mentioned here, you can set a duration that is your maintenance window, tell it to start the reindex, and if it goes, once it hits that max duration, it'll pause the reindex, and then you can schedule it again for another maintenance window. You can manually pause a reindex on your own as well and resume it also. And one of the things that I mentioned here is very little quid pro quo. So most types of indexes and most situations can make use of this new feature. There are very few limitations on where this will work, and most of those limitations are rarely used things anyways. So in most cases, if you go to 2017, this is something that you have access to very easily. So rather than talk about it, let's take a look at an example. So let's close a couple of these things here. Okay, so we're going to make use of another database here, a sample database that we have basically gone in and fragmented the index on very badly. It's in big need of a reindex in this fact.movement copy table. And so what we're going to do here is we're going to show you, I mentioned that it can recover from lots of error conditions. We're going to show you one possible situation that it can recover from. Now, I need to give a couple of warnings before I do this. The error situation we're going to deal with is a server crash. So I'm going to intentionally crash the server. The way I do that is by doing shutdown with no wait. That essentially kills the SQL Server processes immediately. There's no clean shutdown when you do this. This is not a command that you want to ever run, hopefully. And in fact, there's a very high probability that when I do this, I'm actually going to corrupt something within my database. But it's going to illustrate what can be done with this resumable online reindexing. And by the way, this is the reason I'm doing this demo last, is because I don't want to mess things up. I didn't want to mess up anything else that I was going to illustrate to you. If we break things here, it's fine, no big deal. Okay, so we're going to, basically the way this is done, it's very simple. Alter index, rebuild with online equals on and resumable equals on. So very simple. So let's go ahead and execute that, and that's running. So we'll let that run. Now this would normally take a few minutes to run. So let it run a little bit. Now we're going to kill our server. SQL Server is terminating. You can see my connection to the SQL Server just straight up die. If we go in and look in our services, and let's see here, I'll do a refresh. You can see that SQL Server service is no longer running. The processes are dead. So this is a crash situation at this point in time. So we're going to go ahead and start our server back up. And we will wait just a minute here. And then what we're going to do is we're going to take a look at what's in this table first of all. sys.index resumable operations. So let's execute that. Our servers come back up. You can see that our alter index on this movement copy or reindex that we started there is now paused. So even though the server crashed, our reindex did not, we don't lose the progress that we've made so far. And we've gotten a little over 15% through the reindex at this point. So what I'm going to do now is restart the reindex. Now, there's a chance that this reindex is going to fail hard because there's a chance that when I crashed the server, I actually corrupted the table as well by doing that. But we're going to tell it to start back up. And so that's now running. Let's take this and we will open a new query and execute that. And what you can see here is that I'm just querying the table to check my progress on this. And you can see that the reindex is now up to 26%. It's continuing. So we have the ability to essentially continue a reindex even across a crash situation, barring the corruption of our database, of course. And so this is a really big feature for a lot of DBAs, being able to do this. Let's go back here. It's a big feature to be able to resume things like that so easily. It's one of those things that you don't have to worry about that maintenance window now and time out what you predict reindex is going to take, because if you go beyond your maintenance window, run out of disk space, all these various situations that used to just be absolute grief for DBAs, this takes care of a lot of those situations. It's a really neat feature, and it's the last feature that we wanted to highlight today. If you have any questions, now would be the time to send those through GoToMeeting. One of the questions that I do want to address first is, how do you go about using these new features that we've just shown with BTR to SQL or Flex to SQL? Well, much of what we've seen is just going to work out of the box with our drivers because they're features that don't directly impact the driver. But some of these items and other features are areas of active research and development for our drivers. As always, our drivers are in active development, and these new features from Microsoft, along with the ones from Oracle, Postgres, MySQL, they kind of set the course for our development. And as many of you know, we've been hard at work updating Thriftly, and we just had a big release in that product line. But there's definitely more to come in BTR to SQL and Flex to SQL as well. If you haven't done so already, now is a great time to take a look at Thriftly, by the way. When you look at the direction that database vendors are going with support for features that cloud or hybrid cloud enable customers, those are the in-demand features. Thriftly fits very nicely in this space. We've recently added support for JSON Web Tokens, which allows for cross-server authentication and authorization. And we've been making some changes that are being driven directly by you, our customers. The same thing goes for our drivers as well. If there's a new feature you want access to or you need access to, let us know. We expend quite a bit of effort trying to predict what people might need 2 to 3 years from now, but your feedback about immediate or forecasted needs is always beneficial. just one other thing to mention, SQL 2017 is the developer version, of course, is free to download and use for development, and it's very easy to get set up now. The installation has been streamlined significantly from what it was, and it's just not nearly as big of a chore to go through that installation process as it has been in prior versions. And of course, being able to pick and choose what you need because of the way they've separated these products out is also very beneficial as well. So I think that's about it. Thank you all for joining us today. Look for a follow-up email that has some links to various things that'll be useful in regards to getting started with SQL 2017. And of course, we'll be staying in contact with you on future webinars as well.